Hello viewers, you are welcome to Step-by-Step Mathematics Clinic. Today we'll be looking at a question on sets, cardinality, union, and intersection of sets. If the universal set equals to set of 3, 6, 9, 12 up to 30, and P equals is such that X is less than 19 and Q is such that X is a what? Is a factor of 30, where X belongs to universal sets. Roman figure 1. Find number of elements in the universal sets. Roman figure 2. List the elements of P union Q. Roman figure 3. List the elements of P intersection Q. To solve this question, the best thing to do is to study the universal sets. When you study universal set, you see that the numbers are increasing in by addition of 3, and this is what you use to list out all the elements that belong to the universal sets. Because when you look at it, we have 3, then we have 6, then we have 9, then we have 12. It's increasing by addition of 3. So to list out the elements of the universal set, we start with 3, go to 6, we go to 9, plus another 3 will give us 12, plus 3 will give us 15, plus 3 will give us 18, alright, plus 3 will give us 21, plus 3 will give us 24, plus 3 will give us 27, and finally the last element of universal set is 30. All right, now when you look at set P, all the elements are less than 19, but we know that it must be within this range of 3 to 30. So set P, the true elements of set P include 3, 6, 9, 12, 15, and 18, since they must be less than 19. Also, when you look at the second set given, which is Q, we see that we are dealing with factors, okay, factors of 30. That is from 3 to 30. Within these numbers, what are the factors? What are the factors of 30? Factors of 30 include 3, 6, okay, 3, 6, 15, and 30. These are the factors of 30. Now, the first question says, find the numbers of elements in the universal set. All you just need to do is to count all the elements in the universal sets. Okay, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the number of elements, that is the cardinality of the universal set, is what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 elements. That helps us to answer the first question. All right, so let's go to the second question, which is Roman figure 2. Roman figure 2 is asking us to list out the element that belong to P union Q. Union means combination of element of P and Q without repeating a particular element that occur in both sets. So by comparing P with Q using the operation of union, you see that 3, 6, 9, 12, 15, 18, and then we have 30. That helps us to answer question 2. Now let's move on to question 3. Question 3 is P intersection Q. Now what do we mean by intersection? That is, we are to list out elements that are present in both two sets, which is P and Q. So by studying them by observation, you see that 3 is common to both sets, so we write out 3 as the intersection. 6 is also common, and then when you study very well, you see that 15 is common. That is this gives us the intersection of the two sets P and Q. 3 is common, 6 is common to the two of them, and then 15 is common, and that is P intersection Q.